Okay, this is video 3 for section 2.4. Some more factoring. This is kind of using what you already should know and just kind of kicking it up a notch. Okay. So in this problem here, this is the difference, really the difference of two squares. It really is. So if you can rewrite this as 4x squared, that's a perfect square, minus 9 squared. And 9 squared is really 3 squared, right? So it looks like this. So this is 81. 3 squared is 9. 9 squared is 81. 4x squared, this is 16x to the fourth. So when you're factoring this, basically the difference of two squares, you take this, which is 4x squared minus 3 squared, and multiply it by 4x squared plus 3 squared, like that, okay? You might have just, even if just you had 9 here, you could have written 9 here and 9 here and it would have been fine. Now notice you still have, this is done right here, but you still have the difference of two perfect cubes here. This is the same as, I'm going to rewrite this, as 2x squared, like that, minus 3 squared. Okay, 4x squared plus 3 squared plus 9. Can't do anything with that. But this right here is the same as 2x minus 3, 2x plus 3. So you're using stuff that you already know, it's just you're using it in several steps, okay, the difference of two squares. Same thing for this one. We're going to go back to what we already know. We're going to factor out a common factor. This actually should be a square right there. So it's 2p to the 8th plus 10p to the 5th plus 12p squared. So I'm going to factor out a 2 and a p squared. First of all, that's common factor. That's easy. So I've got p to the 6th plus 5p to the 3rd plus 6. Okay. Now you might think you're done, but you're not done. You can actually reverse engineer this one. Okay, so this is a trinomial. This could work, especially if you notice that this degree is double this degree. Okay, 6 is double of 3. This could work. Okay, so I want you to put a p here. Okay, and a p, let's try a p to the 3rd here, because we have a p, and a p to the 3rd here. Okay, because we have a p to the 3rd middle term, right? So let's see, 6 and 1 isn't going to work. How about 3 and 2? We're going to look at 3 and 2, and they would both have to be plus. So notice that if you were to multiply this out, you would have p times the 3rd times p to the 3rd gives you p to the 6th. 2p cubed is the inner terms. 3p cubed is the outer terms. That's going to add up to 5p cubed. And then 2 times 3 is 6. So this is 2p to the 8th plus 10p to the 5th plus 12p squared. This is that polynomial factored. So don't think that you're necessarily done. If you have a situation where you've got a trinomial and this number happens to be half of that number, the exponents, you possibly can factor that thing, okay? So give it a try and see what you can come up with.